Hi, let's continue our discussion on important questions on arithmetic progression part 2. Our first question, question number 7. Which term of AP 53, 48, 43 is the first negative term? So here we are provided an AP. Here given AP is 53, 48, 43 and so on. So we need to find out which term will be the first negative term. Look, 53 is positive, 48 is positive, 43 is positive, then whatever numbers will come positive. But a time will come when a number will start coming in negative, isn't that? So we need to find out which term is the first negative term. We don't know. So we will consider that term as Tn. We'll consider that Tn is the first negative term. If Tn is the first negative term, then the value of Tn must be less than 0. Isn't this? Okay, so let's begin. Here, how much is A? The first term, 53. Common difference D is 48 minus 53 is equal to minus 5. Isn't this? Okay, let's continue. You will say let Tn be the first negative term, that is Tn must be less than 0. Isn't this? We know Tn is given by your formula A plus n minus 1 d equal to A. The first term is 53 plus n minus 1. N is not known, so n minus 1 is copied as it is. D. How much is D? Minus 5. Let's simplify the right hand side. So equal to 53 minus 5n plus 5. We can write this as 58 minus 5n. Is this clear? Okay. After this, we know Tn must be less than 0. Isn't this? And Tn means 58 minus 5n. So we can write here, or 58 minus 5n must be less than 0. Let's simplify this one. Or 58 is less than 5n, or 58 divided by 5 is less than n. And when you divide this 58 by 5, how much do you get? You will get 11.6 less than n. So we can say that from here we can say, therefore the value of n must be greater than 11.6. So what is the value which is greater than 11.6? It is 12. That is n is equal to 12. It means therefore T12 is the first negative term. Is this clear? If you want, you can find out T12. If you find out T12, you will get it a negative term. Is this clear? You will get a negative term over here. You can try this on your own. I hope this question is clear to you. Now let's go to next question. Question number 8. How many terms are there in the AP 7, 11, 15 till 139? So here our first term A is 7. Common difference D is 11 minus 7, that is equal to 4. We need to find out how many terms are here altogether. We don't know. But isn't 139 the last term in this AP? Of course. So we will suppose let Tn is equal to 139. The n over here will present the number of terms in this AP. Isn't this? Yes, of course. The n present in this Tn will represent the total number of terms present in this AP. Okay, we know Tn is given by your formula A plus n minus 1 d, or we have considered Tn as 139. 139 is equal to A, the first term 7 plus n minus 1 is unknown. D, the common difference is 4. Let's simplify this one. Or it is 139 minus 7 is equal to 4 and minus 4. Or it is 132. Isn't this? And this minus 4 will come to left hand side to become plus 4 is equal to 4n. Or it is 136 equal to 4n. Or 136 divided by 4 is equal to n. So therefore n is equal to. So on cancellation how much will you get? It is 4 ones are, 4 threes are, and 4 fours are. Isn't that? So it is 34. So there are altogether how many terms? 34 terms. So number of terms in the given AP is 34. That's it. Question number 9. The pth, qth and rth terms of an AP are A, B and C respectively, so that A in bracket Q minus R plus B in bracket R minus P plus C in bracket P minus Q is equal to 0. So in this case, we will suppose let the first term be small a. No, because small a is already used over here. So let's suppose capital A. Is this clear? Okay, again. So let the first term be A and small d, or if you want, you can suppose capital D as well as the common difference. No problem. Small d, even if you use, there is no problem because the small d is not used in the question anywhere. And capital D, even if you use, there is no problem. But let me continue here with small d and d be the common difference. Is this clear? Okay. Now question has said, therefore, by question. It has said pth term is TP. Pth term is A. But we know pth term is given by a formula A plus n minus 1 d. Isn't this? So instead of TP, I mentioned A plus n minus 1 d equal to this A is copied. Is this clear? So this is equation 1. Again, question has said qth term means TQ. TQ is B. It implies A plus Q minus 1 D is equal to B dot dot equation 2. Sorry, over here I should mention P because N is P over here. Is this clear? Okay. Now let's go to rth term, means TR. Question has said TR is C, implies A plus N minus 1 means R minus 1 D is equal to C. This is equation 3. Is this clear? Okay. Now look, what do we need to prove? We need to prove A in bracket Q minus R plus B in bracket R minus P plus C in bracket P minus Q equal to 0. Isn't this? So over here, A is multiplied to Q minus R. We have A over here. So let's multiply this A by Q minus R. If we multiply right hand side by Q minus R, the left hand side should be also multiplied by Q minus R. Isn't this? Similarly, with B, there is R minus P. So let's multiply this B by R minus P. Similarly, let's multiply this C with what? With P minus Q. Is this clear? Okay. So multiplying equation 1 by Q minus R, equation 2 by R minus P, and equation 3 by P minus Q. Is this clear? Okay. After this, what do we get? When we multiply equation 1 by Q minus R, we will get A plus P minus 1 D bracket closes. We are multiplying with Q minus R. And right hand side as well, we should multiply with what? Q minus R. Is this clear? Okay, let's simplify this one. Or this Q minus R will multiply A as well as P minus 1 D. Isn't this? So first of all, this will multiply A, and again this will multiply this term. Is this clear? Okay, let's multiply. It is A multiplies Q minus R, and then this P minus 1 D will multiply Q minus R. In right hand side, we are copying as it is A Q minus R, which is equation 4. Now let's multiply equation 2 by what? By R minus P. Okay. Now is A plus Q minus 1 and then D bracket closes multiplied by R minus P. Similarly, the right hand side, which is B, is also multiplied by R minus P. Is this clear? Now let's open the bracket of left hand side, or it is A in bracket R minus P plus Q minus 1 D in bracket R minus P equal to B R minus P. This is equation 5. Again, we are multiplying equation 3 by what? By P minus Q. Okay. So when we multiply, the left hand side as well as right hand side should be multiplied. So a plus r minus 1 d curly bracket multiplied by p minus q plus, sorry, it is equal to c in bracket p minus q. Now let's open the bracket of left hand side. We are getting a in bracket p minus q plus r minus 1 d in bracket p minus q equal to c in bracket p minus q. This is our equation 6. Now we are going to add the corresponding sides of equation 4, 5 and 6. Is this clear? So adding corresponding sides of equation 4, 5 and 6, we get, okay, so left hand side will be added to left hand side. So the left hand side of equation 4 is a in bracket q minus r plus p minus 1 d q minus r. Isn't this? Okay, plus the left hand side of equation 5 is a in bracket r minus p plus q minus 1 d in bracket r minus p. Isn't this? Okay. Now plus the left hand side of equation 6 is a in bracket p minus q, then plus r minus 1 d in bracket p minus q. Isn't this? Now equal to the left hand side of equations 4, 5 and 6 will be added. So left hand side of equation 4 is a q minus r. Left hand side of equation 5 is b r minus p. And left hand side of equation 6 c p minus q. Is this clear? Okay. After this, we are going to take a common from here, and from here. Is this clear? So first of all, let me put a together, the terms containing a together, or it is a q minus r plus a r minus p plus a p minus q. Is this clear? Okay, then remaining terms. In remaining terms means this is remaining, and this is remaining. In all these three terms, there is d. So we can take d as common, isn't this? So first of all, let me put them together. So it is plus p minus 1 d q minus r plus q minus 1 d r minus p plus r minus 1 d in bracket p minus q equal to the left right hand side is copied, a q minus r plus b r minus p plus c p minus q. After this, or now from here we are going to take a common. After taking a common, we are left in bracket with q minus r plus r minus p plus p minus q. Okay, now plus Now from all these three terms, we are going to take d common. So d is taken common. Now in bracket we are left with p minus 1 q minus r plus q minus 1 r minus p plus r minus 1 p minus q. Now equal to the right hand side is copied as it is. A q minus r plus b r minus p plus c p minus q. Is this clear? Okay. Now, or this A is copied. Now look inside this bracket. Plus q minus q cancelled. Plus p minus p cancelled. Minus r plus r cancelled. So we are left with 0. And how much is A into 0? It's 0. Isn't this? Okay. Now plus d. Now let's simplify within this bracket. Let's open the bracket within the bracket. Okay. Now when we open the bracket, we are getting pq minus pr. Isn't this? Then we get minus q plus r. Then we are getting qr minus pq. Then minus r plus p. After this, we are getting rp minus rq. Then minus p plus q equal to the right hand side is copied. The right hand side is A in bracket q minus r plus b in bracket r minus p plus c in bracket p minus q. Is this clear? Okay, after this, you can check inside this bracket. We have plus pq and minus pq cancelled. We have minus pr and we have plus pr cancelled. We have minus q, we have plus q cancelled. We have plus r, we have minus r cancelled. We have plus qr, we have minus qr cancelled. We have plus p and we have minus p cancelled. So again in this bracket we are left with 0. So ultimately, or this a into 0 is 0 plus d into, from the bracket we are getting 0 equal to the right hand side a q minus r plus b r minus p plus c p minus q as it is copied. So ultimately in left hand side what are we getting? We are getting 0 plus 0. How much is 0 plus 0? 0. Okay. So right hand side I am copying a q minus r plus b r minus p plus c p minus q as it is. So therefore we get a q minus r plus b r minus p plus c p minus q equal to 0, which was to be proved. I hope this is clear. Now let's go to next question. Question number 10. If the pth term of an AP is q and the qth term is p, prove that its nth term is p plus q minus n. So here we are provided pth term means Tp is equal to q. But we know Tp is given by a plus p minus 1 d, isn't that? Now right hand side is equal to q. This is equation 1. What is a over here? The first term. What is d? The common difference. Okay. Similarly, question has given tq. The qth term is p, which implies a plus q minus 1 d is equal to p. This is equation 2. Now we will solve equation 1 and equation 2 to get the value of a and D. Is this clear? Okay. Now let's try to get the value of A first of all. So to get the value of A, what shall we do? Or let's try to get the value of D first of all. Okay. So subtracting equation 2 from 1, we get, what do we get? When you subtract 2 from 1, this A and this A is cancelled, isn't that? So then we are left with P minus 1 D in the left hand side of equation 1 and Q minus 1 D in the left hand side of equation 2. But since we are subtracting, here comes the sign of minus, equal to, now the left hand side of equation 1 is Q and the right hand side of equation 2 is P. So we have to subtract, it is Q minus P. Is this clear? Or D is over here, D is over here, that can be taken common. So D is common and then we are left with P minus 1 minus Q plus 1 equal to Q minus P, or D as it is, minus 1 plus 1 cancelled, we are left with P minus Q equal to Q minus P. Is this clear? After this, or D is equal to, right hand side Q minus P is copied as it is and the left hand side P minus Q is brought to the right hand side to divide. Or we can write this as D equal to minus in bracket P minus Q. Isn't that? We have taken minus common and the denominator P minus Q is copied. This P minus Q and this P minus Q can be cancelled. So ultimately we are getting D is equal to minus 1. I hope it is clear. So we have got the value of D. Now we need to get the value of A. To get the value of A, we will put D is equal to minus 1 either in equation 1 or in equation 2. So putting D is equal to minus 1 in equation 1. What was our equation 1? It was A plus P minus 1 D equal to Q. Isn't this? Okay. It is A plus P minus 1 D is equal to Q. So in this equation, in place of D, we are going to put minus 1. Okay. Putting D equal to minus 1 in equation 1, we get A plus P minus 1 and instead of D, we are keeping minus 1 equal to Q, or it is A minus P plus 1 equal to Q, or it is A equal to Q plus P minus 1. So we have got the value of A as well. We got the value of D, which is minus 1. We got the value of A, which is Q plus P minus 1. Now using this, we are going to prove that the nth term is equal to P plus Q minus N. Isn't this? Okay. We know Tn is given by A plus N minus 1 D, or Tn is equal to A. How much is A? A is Q plus P minus 1. So it is Q plus P minus 1 plus N minus 1 D. How much is D? It is minus 1. So minus 1 over here. Now let's simplify this one. It is Q plus P minus 1 minus N plus 1. This minus 1 plus 1 cancelled. Then we are left with Q plus P minus N. We can arrange it to get P plus Q minus N. So therefore Tn is given by P plus Q minus N. I hope this is clear. Okay, now let's go to next question. Question number 11. If the ninth term of an AP is 0, prove that its 29th term is twice its 19th term. So here we know ninth term of an AP is 0. It means T9 is 0. But we know T9 is given by A plus 9 minus 1 D equal to 0. What is A over here? The first term. What is D over here? The common difference. So at the very beginning of this problem, you will write language, let A be the first term and D be the common difference. Is this clear? Okay. So or it is A plus 8D equal to 0. It means A is equal to minus 8D. Is this clear? This is equation 1. Then question says, prove that its 29th term is twice its 19th term. So let's find out 29th term first of all. So it is T29. We know it is A plus 28D. Isn't this equal to A? A is minus 8D from the first equation. So instead of A, we can put minus 8D plus 28D, which is equal to 20D. This is equation 2. Again, let's find out 19th term, that is T19 is equal to A plus 18D. So again A is minus 8D. So minus 8D plus 18D, isn't that? Now how much is this one? This is 10D. This is equation 3. Now from equation 2, T29 is equal to 20D. 20D means 2 into 10D. Isn't this equal to 2 same to same and 10D? How much is 10D? 10D is T19. So instead of 10D, we can put T19. So therefore, the 29th term is T29 is twice the 19th term means T19. It is clear? Okay, hence proved. Now let's go to next question. Question number 12. The 6th and the 17th term of an AP are 19 and 41 respectively. Find the 40th term. So here we are provided 6th term, that is T6. How much is T6? It is 19. But we know T6 means A plus 5D equal to 19. Isn't this? From here we can write A is equal to 19 minus 5D. Let's say this is equation 1. Again question has said 17th term means T17. T17 is 41, which means A plus 16D is equal to 41. From here we can write A is equal to 41 minus 16D. This is supposed as equation 2. So from equation 1 and 2, check the left hand side of both the equation is A. It means same. So of course right hand side of both the equations must be same. So from equation 1 and 2 we get 19 minus 5D is equal to 41 minus 16D, or it is minus 5D plus 16D is equal to 41 minus 19, or it is 11D equal to how much? 22. Therefore D is equal to 2. Now putting the value of putting D is equal to 2 in equation 1 or 2, wherever you want you can keep, we get A is equal to 19 minus 5 into D. D is how much? 2. It is 19 minus 10, which is equal to how much? 9. So we got the value of A as 9 and D as 2. So using these two values, we will calculate what? We'll calculate 40th term. Now 40th term is T40. So therefore T40 is equal to A plus 40 minus 1, that is 39D. Isn't this equal to A is how much? A is 9 and D is how much? D is 2. So it is 9 plus 39 into 2. So 9 and it is 78. So it is altogether 87. So 87 is the 40th term. Is this clear? Okay. Now let's go to next question. Question number 13. If m plus 1th term of an AP is twice the n plus 1th term, prove that 3m plus 1th term is twice the m plus n plus 1th term. So here again you will suppose let A be the first term and D be the common difference. After supposing that, question has given m plus 1th term. So T m plus 1th term is twice means 2 into n plus 1th term. So it is T n plus 1. Isn't this? And we have a formula for Tn. Tn is equal to A plus n minus 1 D. Isn't this? Okay, let's use this formula. So, or in place of Tn plus 1, we can write A plus in bracket, instead of this n, what shall we keep? We should keep m plus 1. So it is m plus 1 and this minus 1 is copied. Minus 1 and the d is also copied, equal to 2 into, now this t n plus 1th term is given by a plus in bracket, instead of this n we should keep n plus 1. So it is n plus 1 minus 1 and d. Is this clear? Let's simplify this one. Or it is a plus, okay, plus 1 and minus 1 cancelled. So we get md equal to 2 into, now here a plus is plus 1 minus 1 cancelled. So we are getting and D. Now let's open the bracket, or it is A plus MD equal to how much? 2A plus 2 and D. Is this clear? Okay, let's simplify it further. We can write this as MD minus 2 and D equal to 2A minus A, or here is D, here is D, can be taken common. So we have D in bracket M minus 2N, and here we get 2A minus A as A. So this is our equation 1. Is this clear? Now let's try to find out 3m plus 1th term and m plus n plus 1th, m plus n plus 1 term. Now we'll find out 3m plus 1th term, which is given by a plus n. In place of n, we should keep 3m plus 1. So it is 3m plus 1 minus 1d. Isn't this? Let's simplify this one. Equal to a plus 3md. Again, value of a is d in bracket m minus 2n. So let's put the value of a. D in bracket m minus 2n plus 3md is copied, equal to, now here is d, here is d. So d is common. After taking d common, we are left with m minus 2n plus 3m. D in bracket 4m minus 2n. Now again 2 and 2 can be taken from inside the bracket. So 2d, and we are left with 2m minus n. Is this clear? Now again tm plus n plus 1th term is given by a plus m plus n plus 1 minus 1d. Isn't this? Okay, equal to, now the value of a. What is the value of a? A is d in bracket m minus 2n plus, now within this bracket plus 1 and minus 1 cancelled. So we are left with m plus n d. So this d and this d is common. So d is common, and in bracket we are left with m minus 2n plus m plus n. Isn't this? So it is equal to d 2m minus n. Is this clear? Now compare this and compare this. So what is this? This is t 3m plus 1th term. So let's say this is equation A and this is equation B. So from A and B, from A, t 3m plus 1 is equal to 2 into d in bracket 2m minus n. Now equal to 2 into this d in bracket 2m minus n is same as this one, which can be replaced by t m plus n plus 1. Isn't that? So we can write t m plus n plus 1. So which has to be proved.